Hi everyone, my name is Joanna. Rebecca is here to help us today. So a quick introduction before we get started. Hopefully everyone has the website I kind of set up. Let me share my screen already. So hopefully everyone has that, this website. I'm going to paste it on the chat, but I need to stop recording to do that. Sorry. Just so if you don't have it, you can open it. I'm not expecting you to actually, sorry, I'm having, my computer is slowing down. I hope that doesn't mean it's going to crash. Yes. Okay. So hopefully everyone has that. I don't expect you to actually follow the materials, but because I'm going to be following in live coding everything. But if you do want to, or if you then want to check them afterwards, then they're there. There's a bit of an introduction. I wanted to introduce a few things. So this course is based on the materials by the Carpentries, which is a global community of people who want to kind of spread knowledge on coding. And if you go to the Carpentries website, you'll see there's 3 different types of carpentries. There's the software carpentry, the data carpentry, and the library carpentry. The R course belongs to the software carpentry, and there you have other courses like Unix, Git, Python, etc. And there's 2 different courses in R. One of them, the materials we're going to introduce today are sections of one of them called R for Reproducible Science, but there's another one as well. Some of the contents are kind of overlapping, but there are unique contents in both courses. So this is just an idea for you to take if you want to then expand your training. This course is only 2 afternoons, so we can't actually cover everything that's available on the website, but you can go, and the tutorials are self-explanatory, so you can just do them yourself. Today we're going to, this is the rough schedule. I'm gonna try and stick to it, but things might take a little longer or be a little shorter. First, I'm going to introduce you to R and R Studio. I'm hoping everyone has R and R Studio installed. If not, get on it now and let us know if you have any issues. Then we're going to talk a bit about seeking help and what's the best way of solving your problems when you're actually alone coding and you have any doubts or you want to know how something works. Then how can you do that by yourself? Because in a course it's very easy, right? We're following something that we know should work. But when you're at home then coding or in the office coding by yourself, you come across errors and problems. And how can you solve and clarify your questions then? Then we'll have a short break of about 10 to 15 minutes, and then we're going to get into data structures. And then next week we'll continue with exploring data frames, matrices, etc., how to subset data. Then another break, and then we talk about control flow, which includes like for loops, if statements, etc. So as you can see, it doesn't include everything. We are not going to be talking about plotting, for example, but we can. But you have materials about that in the website. If you have any questions at any point, please feel free to unmute yourself and just interrupt me. If you raise your hand, I'm aiming to see it, but I might not see it. So Rebecca might have to stop me or ask you in the chat. You can also post questions in the chat because she'll be monitoring. And then if it's something a bit more sticky, a bit more complicated, you might go into a breakout room to try and solve it. But hopefully we're not going to have the need to do that. But there's that option. What else I was going to say? If we a lot of the times when we learning R or coding, we learn the most when we encounter errors. We learn how to read the errors and interpret them and find the solution. I might encounter some errors here, which I'll try to explain, but if you encounter an error that you can't solve or that I don't explain because I didn't have the same error, I would really encourage you to say something, maybe share your screen so we can all have a look at the error and learn something from it. Like, you don't have to, but it's a great learning opportunity if when people do that. So you know, if you feel comfortable doing that, you'll be very welcome to do it. Right. So let's start by opening RStudio. I haven't opened mine. So hopefully someone is doing a bit of an echo. Okay, let me move this to another window. Yeah, so if you keep yourself muted, and then if you have any questions, just unmute yourself. You should be able to do that. So let's have a look at, hopefully everyone has their RStudio open. If you don't, tell me and I can wait a little longer. If not, I'll just continue. Let's talk about the basic layout of RStudio. So here we have the console, and the console is where you type your code. Essentially, you type anything and then you get an output. So let's try, you know, the most basic function of R is to be a calculator. So you could just use it as a calculator. I mean, it's a bit too fancy for a calculator, but you can just use it as a calculator. So if I do 2 + 2 in the console, and I press enter, it will return 4. Okay, and this little arrow here means that R is waiting for an input from you, so it's ready to go. So if this R is not showing and is showing, for example, a plus, it's because you haven't finished a certain input. You haven't closed something, or you forgot to give something more. R is still waiting for more input from you. But if there's an arrow, then it's ready to go. It's waiting for your input. Here we have our environment. So the environment is the things that we have loaded into the R memory that we created. So we'll talk a bit more about variables and objects and things like that later on. But anything we create in R gets stored in the environment. And I'll point to it when we create something and it shows here. Right now, the environment is empty. Hopefully yours is too. If yours isn't, it's probably maybe because you've used R, you saved something there. And then when you reopen it, sometimes RStudio remembers your environment. And there's options to, if you go to tools and global options, you can change that. But I'm not going to go into detail, but just so you know, there's that possibility. Here you have a series of tabs. The first tab is your files, and this is basically just your computer. So you'll see something very different from me. RStudio takes me directly to my home page, my home folder, sorry, and then there I have all my folders. You'll have something different, but it basically, why am I showing you to yourselves? Let me just move this here. So yeah, basically it's just your computer and how your folders are displayed, and then you can just navigate to anything. So I'll go to my documents, for example, and you can create a new folder here. So I'm actually going to create a folder for today's course in my documents page, just to show you that you can do that. So our tutorial, that's it. There should be, yeah. Then I open it and it's empty. So these are the three windows, and then there's a fourth window that you can't see yet, but you can open a text file that it's going to be your script. The script is exactly what the name indicates, which is instructions for R to perform something. So I'm going to be writing all the commands I'm doing in a script today. So to create a script, you go to File and New File, an R script, or you could have just gone here as well. And it's the same. It's New File and then R script. And you see it just opens a file. It's not saved anywhere. I'm going to save it here. I always like to save my scripts with meaningful names that I can then come back, you know, even years later and know exactly what they do. And in folders with dates, you know, the file names with dates. So it's up to you how you save your scripts, but it's very useful to have scripts that with names that mean something. So I'm gonna go to File. Sorry, I didn't show how I did that. File, Save As, and then I navigate to the folder where I want to save my script. which in my case is the folder I created just for this tutorial. And I'm gonna save it as tutorial script, and then I'll put the date of today like this, and then I'm gonna save it as .r. So .r, it's basically just a normal text file. So it's the same as having .txt. The format is exactly the same. It's plain text, but it's interpreted as R as an R script. So if you wanted to load it directly to R and run it without having to copy and paste or select anything, R will understand that that's an R script, but it's just basically a plain text file. So hopefully everyone has a script now and everyone kind of understands what the four kind of windows are. If not, give me a shout, I can explain again. If I want to run something in R, I already showed that I could just type in the console, but in the console, there's not going to be a clean record of your steps. I mean, you could export this as a history file of R, but it's going to be, you're not going to be able to rerun it again without cleaning it up from the errors or the output or anything like this. So it's best practice to keep a script well documented with every step you did in the analysis, because then again you can just open the text file and rerun your analysis or change it and document that really well. So from now on, I'm gonna aim to write everything in my script and kind of remember to save it as I go along, and I encourage you to do that. So again, I already showed that R can be a calculator, so I'm gonna do that again. I'm gonna do 1 plus 100. Actually, let me do that. 1 plus 100, and now it's just on my file here. It hasn't run in the console, and I haven't seen the output. So to run in the console, you have a few options. You can either select or just click on that line, and if you click run here, run the command or selection, it will just run that line you're on, or the entire selection. And if I just press that, it gives me the output of 101 here in the console. You can also use shortcuts. So again, if you select several lines, or this one line, or if you just have the cursor here, and in my case, because I'm in Linux, but in Windows it's the same, I press Control Enter. If you're in Mac, is, I believe, Command Return. Now I'm going to, there's a page, let me pull it here. There's a very helpful page in RStudio, which kind of lists all the keyboard shortcuts. So if you prefer to work with shortcuts instead of pressing buttons, these are quite this is a great list. So I'm going to copy that. And does anyone know how can I find the chides here? Okay, there's a few questions about installing R. What should I do? How many people? One person's having difficulty installing R. How many people are? Can people tell me if they're still installing R, so I can gauge how many people? Anyone? Is anyone still installing R? Can you hear me? Okay, well, no one is.
Yes, we can hear you.
Okay, good. Is anyone still having issues installing R and RStudio?
Hi, I think it's only me. I was trying to install it 2 times and gave me error that the access is denied.
Access is denied. Are you trying? Is this a personal computer?
No, it's a uni computer. Right. It's a uni laptop. Yeah.
So which folder are you trying to install it on?
Just the down, you mean in which folder? I'm just installing in downloads.
Yeah, so you might not have permissions to do that. Sometimes that's a problem. Maybe try another folder, like maybe the documents folder or something like that.
Okay, so I
Sometimes
do.
with the university computers, you're not allowed to install anywhere. So just try maybe install it in a more personal folder. I don't know.
Okay,
I
okay,
think
I
that will solve
try.
it. Sorry. Okay, I'll just keep going and hopefully you'll be able
Yes,
to
so I'll
catch
let you
up.
know.
Pay
Okay.
attention anyway. Um, Another good shortcut. So I put it on the chat, the list of shortcuts if you want. Another shortcut that I like is in Linux is Control S, because it saves my script. So you saw that it was red with an asterisk, and now I press Control S and it has saved my script. So I use that quite a lot. Let me actually see how it is in Mac. This should be the same in Windows, I believe. It's Command S in Mac. Okay, so you have a long list of shortcuts to explore. And what I wanted to show you as well is when I said that when there's an arrow, it means that R is kind of ready to go to receive more input. I'm going to show you what happens if you don't complete a command. So let's say I kind of had a typo. I forgot to write the 100. So I write 1 plus, and then someone distracts me. I don't write the 100, and I press run. Now there's a plus here, and it just means that R is still waiting for an input. So if I had a minus, it would be it'd still show plus. It just means give me something else. I can't work with this. It's just 1 plus. I don't know what you want me to do. So to get away from this, so if I press enter, it just keeps asking for input. I can't get away. To escape this, you press the escape key, which should be at the top left corner of your keyboard, and I believe it's the same for all operating systems. So if you try that, I just press escape, and it returned to it just forgot what I'd done here, and now it's waiting for something else. It's fine. So another good thing to do is to comment your code and your script, and that means that you can add text to your code, that it's not going to be interpreted by R. R is going to know it's just text of you explaining to yourself what you're doing. It doesn't have to do anything with that text. So a way to do that is to use the hash key, and the hash key just tells R anything after that hash key is a comment. Don't try to implement it. So if I pressed hash, and then I said, actually, let me press hash here, and I said using R as an operator. And I'm probably not going to have time today to be commenting as I go along, but I really recommend you do that on your day-to-day, because it's very useful. And you might think that you'll remember why you did something, and then 3 years down the line you come back to it and you really don't remember why you did a certain bit of code. Whereas if you comment your code really well, it's informative for you, but it's informative for anyone who might use your code. So because this is not this is kind of supposed to give demonstrate an error, I'm just going to put a hash before as well to comment that out, just so if I rerun everything, it doesn't get stuck here. And what else I should show you? Okay, let's continue with the operation. So I showed you how to add something 1 to 100. Let's use a few more examples. So I can do multiplication. I can do 3 plus 5 times 2, and R uses the rules that we're used to in math. So we will do the 5 times 2 first, and then add the 3. So if I run that, go, it did 5 times 2 and then plus the 3. The same with a division. If you want the sum to come first, you use parentheses. So exactly like you would do if you were doing maths at school, or in your normal life. And that doesn't have to be at school. I just don't do it usually. And then if I run that now, it does give me the 16. So now it did add the 3 to the 5 and then multiplied by 2. And it's the same for division. And to do exponential, you can do 2 to the power 2, or not exponential, to the power. So this is the symbol, the little hat symbol in my keyboard is above the number 6. I don't know if in yours is the same. And yeah, it gives correct. To do a division, I can do 2 divided by, let's do 10,000, just to see what the output of that is. And that gives me 2, and then that gives me scientific notation. When there's too many numeric digital places, it will transform this into scientific notation. So you can also do mathematical functions, some standard ones. So I can do the sin of 1, for example. And this, what I just typed here, is a function. So in R has already coded within it certain code to help you achieve an action, and these are functions. So this is the function sin, and then I give it an argument. In this case, I want to give to sin the number I wanted to calculate it. So you do sin, open brackets, then the number, which is the only argument you're giving to the function, and then you close the brackets. We'll talk about functions a bit more later when we're looking for help. We're looking for how to, we're explaining how to look for help. Other mathematical equations or functions, the log function. Again, it's a function in R, so you open brackets, and inside you put the number you want to calculate the log of. If I run that, you can see it gave me the log of 1 is 0. I'm just going down, entering empty lines just so you can see a bit better. You can also do the logarithm, the 10 logarithm. So that's log 10. That's a separate function from this. So in this case, it's the log. This is log 10. Open brackets. And again, let's calculate the log 10 of 10, which is 1. You can do e to the power of something. So in that case, you have a function for that, which is exp. And let's do the exp of 0.5, which is this. So you can see there's a few of mathematical functions you can use in R that are already coded in R. So you don't have to go and calculate the whole thing. Next thing, how can we compare one thing to the other? So you can compare 2 different things with the equality symbol, which it's not the equal one, it's the equality, which is 2 equals one after the other. So let's say I want to ask R, is 1 equals to 1, okay? And in this case, I wrote 2 equals, and the answer to this is true. So the answer here is, there's 2 answers possible. It's either true or false. And of course, we know that 1 is equals to 1, but you could be, you could be comparing 2 objects that you don't know what's inside. So obviously here it is true, but what in other scenarios is a bit more useful than here. You can also ask if it's not true, if it's not equal. So instead of doing equal equal, I'll do exclamation mark equal. So if I do 1 exclamation mark equal 2, for example, this was going to give me true, because 1 is not equal to true. That's to 2. That's a true statement. If I do 1 exclamation mark equals 1, the answer to this is going to be false. Right, are there any questions at this point? Because I'm not really looking at the chat. Okay, seems everyone is okay.
Sorry. Sorry, Joanna. So because I was a bit late. So when I just type something in the script, it doesn't give me the answer in the console.
Yeah, so if you just type it, you're just writing to a text file, which is this text file here. To run it, you have two options. You can either, let's go back to this one, okay? You can either select all the lines you want to run and press run.
Okay.
Or you can if you're in a Windows or Linux, you can do Control Enter. If you're in a Mac, you can do Command Return. That's if you want to use a shortcut, but you can just use the run button here.
Yes, great. I got it.
You just want to run the one line. It's enough to have the cursor on that line and click run, you see, and then you just run that one line. If you want to run several, then you can select all the lines and click run. Does that work?
Yes, it's working. Okay. Thank you.
Right. If there aren't any other questions, no? Let me save this. Other ways of comparing is I can ask for example if something is less or bigger, smaller or bigger than something else. I can do 1 smaller than 2, and here is the little arrow pointing in the direction in this direction. So mine is above the comma, and this is true. I can do smaller or equal to, so I do 1 smaller and then equal, then 2, for example. This is going to be true again. So in this case, it's always I never know the order of these two. I actually never know if it's this or this, or this. So I often try it and then get an error and then I substitute it, just so you know that it's, I somehow I find it really hard to remember this. So I often do this and this. I know it doesn't make sense. This makes more sense, but I never know. And then it says error, unexpected, this symbol in this. So he started using this and then it was like, this doesn't make any sense. So just swap them if you're like me and you get that error constantly. And you can also use the greater. So I can use 1, it's greater than 0. Let's actually do a false. 1 is greater than 30. And the answer is false, of course. So you can do quite a few comparisons, which now seem useless because we know the answer to all of this just by looking. But when you come to compare other things, that it's actually, this is really useful to know. And you can also do greater or equal to. And in this case, I would do is, let's reverse it, 30 greater or equal than 10. True. And again, in this scenario, I never know the order. I always have to try it. So let's talk about variables. Okay, so this is all very good. I'm getting an output, I'm testing things, I'm asking questions, but I haven't saved anything for later use, for example. And a way to do that is to create a variable. And a variable is just it's basically a name or a container for something. So let's say I want to store the solution of 1 divided by 40. I don't want to keep having to write 1 divided by 40 every time I need to use that number. So I'm going to say that I want to save that in the variable x. And to attribute 1 divided by 40 to x, I make a little arrow and then the minus sign. So you can see that this is indicating that I want to store 1 divided by 40 in X. And you can also do this in the other orientation. You can put X on this side. So I could equally do 1 divided by 40, saving in X. So these are the same thing. So let's run that. And now, so you basically just run it once and then replace the value of X with this because it's the same. So it's saved here in my environment. I now have a variable called X, which is this value. So it tells you the name of the variable and then the value of the variable. So X, as you can see, is like a container for a value. It's a variable that I can now use later in anything I need. We can also just, if you didn't have this, or if you don't like to use this bit, you can just type X and run it, and then you can see that R has now saved this value in X. So every time you type X, R knows that this is the value of X. And variables can be many different things. In a bit, we're going to look at the things that are allowed or not allowed in variable names. But be careful when saving variable names that are they should be simple enough and meaningful. So they should be something that anyone looking at your code can kind of guess what they are. But if they're too simple, sometimes they replace things that already exist in R, like functions. So for example, if I'm calculating the mean of something, and there's a function called mean in R, maybe I don't want to save it as mean just in case I'm going to mess something up. So maybe I'll save it as mean of something. Just a word of warning in that case that, yeah, sometimes it's, you want to be careful with the name of the variables there. And now I can calculate things with X. So for example, I could do the log of X. And R knows that X is 1 divided by 40 because I already created that variable. So if I run log of X, log again, it's a function that already exists in R. And it returns the value of log of 1 divided by 40. Now, another thing to keep in mind is that you can replace the name of a variable with something else. You can decide, I made a mistake, X is not that, X is something else. Let's say that actually I want to update the value of X with 100. Then you just update it and you'll do, again, you save 100 in X. And if you run that, you can see that it has updated the value of X. Again, be very careful doing this. If there's something that took you ages to calculate, you might think very carefully if you want to replace the value of that variable, or if you want to create a new variable like X2. So it's always a balance between creating too many things, too many different variables, and then it becoming confusing, your code becoming confusing, and you have too many things in memory. And if you're working with really large data sets, that can actually create a problem and make R really slow. But you don't want to also keep replacing the same variable just for the sake of using just one variable, because then you might lose something that you've created that was actually important. You can also save in a variable the result of a calculation with another variable. So let's create a variable called y. And in y, I want to put x plus 1. So to the value of x, it will add 1. And now I have y, which is 101, which is x equals 1. Or I want to do z, which is x times 2, for example. Okay, so now I have 3 variables. You can also, this is what we call the assignment operator, or the operator of assignment. There's another one you can use, which is the equal sign. So I could also do x equals 2. Okay, and if I run that, it updated the value of x with 2. I don't like to use equal almost never, just because you can't then reverse. I actually, people from other languages get really annoyed with the operator because in other languages it's just equal usually, and I actually really like the flexibility of being able to put it in each whatever order around I like. So you can use this. In certain occasions it doesn't really work, so be wary of that, and be wary that you can't do 2 equals x, because now it's going to try to save x in 2, and 2 is a number. You can't use that as a variable. So if I run that, it says error in 2 equal x, invalid, left hand side to assignment. It's one of those cases where the error in R is very cryptic, but you kind of get a hint here that left hand side to assignment, to me it says that there's something weird about me trying to assign this to this. Again, I'm going to comment that out because it's an error and I don't want it to be throwing out errors if I run all the code again. So now let's do like a 10-minute exercise. I'm going to put it in the screen so you can see. And this is the challenge 1. Try this, and then I'm going to ask a volunteer to let me know which of these worked at variable names and which one didn't. So try to assign a number or something to these using the assignment operator like we just practiced. So let's come back at 10 to 3. So yeah, Rebecca just reminded me something I said I would explain, and then I forgot, which is there is a shortcut to do the assignment operator as well. So let me quickly just show you here. Sorry, I'll leave the exercise there. But in Windows, and I believe in Linux as well, if I do Alt plus the minus sign, you will automatically do the assignment operator. And in Mac is Option minus. So if you're lazy like us, like me, you might want to use a shortcut to do the assignment operator. Okay, hopefully you had a chance to try those. Let me open again our studio here. Does anyone want to tell me what the conclusion, which conclusion they got to? Which ones work, which ones didn't work? Right, no one wants to, so that's fine. I'll do it.
No, it's all in the chat.
Put it in the chat.
Oh, in the chat, sorry.
Mm-hmm.
Okay, yes, so yes, so the underscore age doesn't work, so you can't start a variable with underscore. Min minus length doesn't work, and that's because you're using the symbol of minus. So you're trying to, R is thinking there are variables created there with numbers, and it's trying to calculate the subtraction of those. And you also can't start a variable starting with a number. What about the dot mass? Does anyone kind of understood what that did?
It didn't really give an error, but it just didn't show a variable. So I guess it was either sort of invisible, or it did something, but it didn't give an error.
Yeah. So it created, so if you did dot mass, it creates an invisible variable or a hidden variable, it's more correct term. And those, I never had the need to create a hidden variable, but those are exist in R because let's say you are using an external package, a package created by someone else, and the R needs to create a lot of variables in the calculation of something complex. It'll be a bit of a bummer if it just threw all those variables at you, and then when you go to list the values you have in R that you created, it would always also show a list of loads of variables of things that you didn't directly create. So it uses hidden variables to kind of hide, processes and hide things that it had to create in the process of calculating something. But you can also create a hidden variable if you want to. So that'll be dot mass or dot anything. So let's try that. And if I run it, it worked, but there's nothing here. So we'll see in a bit how we could list all the variables and objects we have. So objects is exactly what the name implies. It's everything created in R. So it doesn't have to be just a variable with a value. It could be a data set, an entire data set, which could be in the format of a matrix or a data frame. And we're gonna talk about all of these today or next week. So an object is just something we create in R. And I'll show you a way of listing all of those and a way of listing all of those, including any hidden variables in a bit. But first I want to talk about vectors. So you can have just the number, or you can create a vector, which basically would be a set of values in a certain order, and all of those need to be of the same data type. Again, we'll talk a bit about data types later, but just bear in mind that vectors need to be all in the same data type. So it could be all numbers or it could be all letters, but yeah, they should be the same data type. So let's generate a vector of numbers of 1 to 5 and see what our gives us. So if I do 1 and then I'm lazy, I don't want to write 1, 2, 3, 4, 5. So I'm going to do 1 colon 5. Okay, so this is the way I'm telling R that, do all the numbers in between 1 to 5. So if I run that, it outputs 1, 2, 3, 4, 5. Okay. I can also do calculations with this. So let's say I want to calculate 2 to the power of 1, 2 to the power of 2 to the power of 3, 2 to the power of 4. So I'll do 2 to the power of 1 to 5. And I have to put brackets, sorry, obviously. Okay, so I'll have to put brackets here in my vector. And now we ask calculator 2 to the power of 1, 2 to the power of 2, 3, etc. I can also say vectors in a variable. So let's say I want to replace the value of x with a vector of 1 to 5. So again, I do the x, the assignment operator, and then I'll do 1 to 5. And if I run that, it now is telling me that x is a vector of 1 to 5 here. And then in like we did here, I can now use the x for the same calculation. So I can do 2 to the power of x, and it will give me the exact same result as it did here. It'll calculate 2 to the power of 1, 2 to the power of 2, and so forth. And so forth. Sorry, I'm just keeping an eye out if anyone is coming in, because currently I can't make Rebecca co-host. So now let's go back to when I said there's a way of listing your all the objects you have in your environment. I mean, if you're using RStudio, you might not need to do that because you have it here, but you might just be using R, or you might be using R within a server. For example, if here in Birmingham, you could be using Blue Bear as the supercomputer at Birmingham. And there you can use RStudio as well, but you might just simply use R, and then you wouldn't have this kind of nice additions that RStudio has. You'll just have the console. basically. So if you wanted to list all the objects you have in R, you use the function ls for list. So ls, and because it's a function, you have to give it the brackets. Now, a function, you would usually have to give it an argument. In most functions, you'd have to give it something inside. So remember when we did sin of 1, yeah? So here the 1 is the argument. In the ls function is a case where you don't necessarily need to give it an argument, because all the possible arguments are optional. There are options you can add to ls to kind of change its behavior, but you could just run ls and with the brackets, and that will give you the list of all the variables or the objects you created. So in this case, it tells me that in my environment, I have a variable called x, another one called y, and another one called z, and that's exactly what we have here. Now, an optional argument you can give to ls is to tell it to list all variables, including the hidden ones. So if I do ls and inside of the brackets, I do all equals true. Okay, so I'm saying show us all, and I know that I need to put all because it's the name of the argument I need to give it. Sorry, actually it's not all, it's all dot names, I think. Let's try that. And now I have 2 hidden variables, all names true. I have the mass, the hidden variable I created, and you can see that R itself has created a hidden variable that I don't know what it is, but I'm not that interested. But if I want to list all the hidden variables, I just use this argument. And this shows exactly what I was saying, is that R will create hidden variables that are not necessarily visible to you to make calculations. Now, why do I need to use the brackets in ls? Because all the functions in R are also an object. So if I don't tell R that I want to use it as a function with the brackets, with things inside, if I just type ls, it would literally just output the code that was used to code this function to make it work. So obviously I don't want to do that unless I want to see how it was coded. But if you just type ls, you would output the code that was used to code the function. So I'm going to comment that out. What else? Another good function that's very useful is the remove function. So let's say that I have variables here that are not necessary anymore, and they're kind of annoying me because I made them by mistake and I don't need them. I can use the remove function, which is rm, and then let's say I want to remove the z object. So I'll just do this, and now it has disappeared from there. You can also remove all variables. So let's try that. Be careful using this on the day-to-day. If you do rm and then if you do list equals ls, what you're basically saying is, equals. What you're basically saying is I want to remove a list of things, and that list of things is everything I have in ls. Okay, so it's going to take the output that we just saw of ls and give it to rm to remove everything. So if I run that, now my environment is empty and all the variables I created are gone. This is another reason why it's important to keep a script, because I could have done this by accident, and then I want to recreate some of the variables. I can just go up and rerun that bit of code. So keep in mind that this is a very useful function, but it can be a little bit problematic if you remove something that you then it took you days to generate or something like that. The next bit of the lesson is to show you how to install packages. I'm not going to actually be installing packages because it can take a long time, and people might have problems with permissions in their computers if they're using university computers. So it would be a long time to actually solve all of those. But I'm going to show you the functions that are used to install packages. So a package is, so R comes with a set of standalone functions and functionalities. So if I want to list everything in my environment, I use the ls. If I want to remove something, I use the rm. If I want to do the mean, for example, I want to do the mean of 1 to 5, like we just did with the mean, sorry, mean, not men. This is the mean function will calculate the mean of 1, 2, 3, 4, 5. So a vector of values. So in that case, it's 3. The minimum, the maximum. So there's a set of functions that come with R, and you don't need to do anything to use them. But sometimes you might want to do something that doesn't come with R. And so people develop additional software. So they're like add-ins, basically. Additional software to be added to R. It's coded in our language. And once you install it, you can then use the functionalities of that package. We call it package. So an example of that is, for example, ggplot2 that a lot of people use. You can just use the normal plots in R. R will do a scatter plot, a bar plot, box plot, all of those. But sometimes people want like nicer looking figures for their papers, or they want something a bit more complex that the plots in R can't really do. So they'll use packages like ggplot, ggplot2 that will give those functionalities to R. But you need to install them. And to install a package, usually if it comes in, if it's in the kind of main repository of packages in R, which is cran, you can type install.packages, and then inside the name of the package with quotation marks. So let's try ggplot. I mean, I'm happy for you to try it. It might just take a little bit to run. I'm not going to personally install it right now, but this is what you would do. And once the installation is over, you can load that package with library. And now you don't really need to use the quotation marks, because R already has in its memory that there's an object, which is a package called ggplot2. If you want to update the package, you use update packages, and then the name of the package. And then if you want to remove it, so uninstall it completely, if it's something that's giving you grievance or generating some problems in your software, and you want to remove it and start over, you can do remove packages and then the name of it. Okay, so this is just a few examples of how to install ggplot, update it, remove it. If you're in RStudio, I believe you can go to tools and install packages as well. So you can do it through here. And then you see that the main repository of our packages is called cran. Yeah. And then you can also have the file, the actually source code locally. So if you're having issues installing through cran, you sometimes can go to the website of the package, download the source code to a local folder and install it via this option. And then you just write the name. So in this case, I'll do ggplot2. It actually recognizes it. And then then install to library. Now this is my default. Again, if you're having issues installing packages due to permissions of your computer, you can change where you're installing it. You then just need to make sure when you do the library, you're calling it from that. So let's cancel this. Actually, you're calling it from that folder. And I believe what you do is then add. So you do comma. So a comma will separate the different arguments you give to a function. So the first argument is the name of the package. The second one, I can write lib equals, and then the folder. So in quotation marks, I would have, I don't know, something like home, blah, blah, blah. So where you install the package, you can give it lib. I believe this would work. You would have to test it. Would have to double check, but I believe this is the way of then loading it if you installed it not in the default folder. Are there any questions about installing or anything?
Yeah, Joanna, kind of stupid one. When I am filling in, like if I type in update.package bracket, it automatically puts a apostrophe, not the quotation marks. Is that going to create an issue? Should I have the double?
You mean this one?
Yes.
Yeah, so it doesn't really matter. I think R doesn't mind if it's double quotation marks or just a single quotation mark.
Okay, thank you.
In most cases, I believe. I sometimes use this and sometimes use double. Yeah, it doesn't, I don't think it matters.
Great, thanks.
Another function that I wanted to tell you in the beginning, because it's not in the course and I forgot because it's not in the course, it's actually how to change your working directory. And I should have actually said this in the beginning. I don't know why it's not in the course actually. It's a bit strange. So when you load R Studio, it will automatically put you in your home directory. So if that's your computer, will be in my case, will be this folder. If you're in a server in Bluebear, for example, it will throw you to your home directory there. But you might want to change it to a project folder. In my case, I wanted to change it to the R tutorial folder, because if I'm now outputting anything, so writing anything from R into my computer, let's say a table or a plot or something like that, I wanted to go directly in there. You can change your working directory. So the first function is to check your working directory, which working directory you're working on. Again, in RStudio, I think you can go to File, and then I think Edit. No, there's a way.
Under Session.
Under Session, thank you very much. So in the Session, you can go Set Working Directory, and then change your working directory like this, to source file or choose directory. But I like to do it in code. So to get your current working directory, you can type get WD. So WD stands for working directory. And again, this is one of those functions where you don't need to give it any arguments. So if you run that, it'll tell me I'm in home / my username. That's my home directory. If I want to change it to the documents R tutorial, I can go to set working directory, and then quotation marks, again, it can be single or double, I believe. And here I have two options. Because I already know I'm in home Vienna J, I can then just type the rest of the path. So I'll show you what that means in my computer, actually. So this is my home, yeah? If I go to documents and then our tutorial, this is what I want to change it to. And this is an addition to home Vienna J. So I could just, I'm going to copy everything. No, I'm going to copy just this. I could just do this. And now you'll know to add this to this. Actually, I need to start it with a slash. Bear in mind that when you are working with path names, so this is a path to a place in your computer. In Windows is the only operating system where the slashes are the other way around. So they'll be like this. So you have to change them all when you're working in R to be /. So if I run this, cannot change working directory. Why? I have no idea. So this is an error. Let's see if it doesn't like that. Okay, so I added a slash, but it didn't like that I had the slash in the beginning, because it probably has a slash at the end of this, even though it doesn't show. But this is a way of changing it, is that I just go inside of every folder. I like to personally use full paths just to avoid any mistakes or any problems. And what I mean by that is if I do set WD, quotation marks, and then I do the whole thing from home, from the beginning, and then like this, sorry. And now I know that it's definitely changing to this folder that's in this folder, in this folder, in this folder. That's a personal preference, but I like to use full paths. And full paths are great as well if you're saving a document. Let's say this is my working directory, but I have a separate folder just for plots, then I can write before the name of the file the full path of where I wanted to save that plot. And we can have a look at this later, I believe next week, when we're working with data sets that we are writing to the computer and then uploading into R, and then you'll see what I mean. Right, I think it's time for a break. We are already late. I already knew this is going to happen. So when we come back, we'll look at the seeking help, and hopefully we're not going to be too much more delayed. So let's do the break now. Let's come back at maybe 25 past. Is everyone? Right, so I'm just going to restart. I hope everyone is back from their break. Let's talk about looking for help and how, you know, when you're alone coding and you can't just unmute yourself to ask a question, how can you solve something? So this is not official advice, but my advice is 99% of the times I solve issues by Googling them. And so let's try that. If I say how to change directory in R, right? And there'll be loads of articles and even pages in R answering your question. And the likelihood is that if you're getting an error, someone already had one. So Stack Overflow, for example, is a forum where people ask questions and then you have people answering. Now, bear in mind that in these forums, you have people who can be quite rude answering the questions, but if you just ignore that, they usually are quite useful, especially if you're using a package, a specific package, and some of the developers of some packages, they keep an eye out on forums and answer questions. So that's actually really useful. Also saying this, I've used R for nearly 9 years and I never had the need to post my own question on forums, because there's always someone who's asked the same thing before years ago and someone answered. So all I need to do is to go through like my Google results and actually look for the best one that I think might solve my problem. But a good way to look for help as well is to try and understand what the function is doing. So for example, if I want to know exactly what setwd does and what arguments I need to give it, I can do two things. One is help. So use the function help, and then inside you write setwd, or for the exact same results, you can do question mark, not set, it's, yeah, setwd, sorry, setwd. So if I run that, I'll go to a help page. So shown here, if you're just using R, it will show in the console, but RStudio shows it quite nicely here. So if I just pull that up, every function has a help page, and it will have a description. So it'll be, this is actually a joint help page for getwd and setwd. This is not that common. Usually each help page is for one function, but because these two are quite related, they created just the one help page. So get or set working directory, and then it explains what the two functions do. Getwd returns an absolute file path. So again, that's the full path that I was talking to you about, representing the current working directory of the R processes, and setwd is used to set the working directory to dir. Now the usage, it tells you how to use the function, and inside here, so each function can have many different arguments. A lot of those arguments will be optional. You see how we did all names equal true in list. That was an optional argument. I didn't have to specify anything. There's a default behavior for that argument, but if I wanted to change the default behavior, I would have to specify it. When in the usage here, it comes with an argument inside. These are the mandatory arguments. So getwd will work with no arguments, but setwd, you do need to give it one argument. What is that argument? Is this one. dear, a character string tiled expansion will be done. This is a very poorly described, it's a very poorly explained argument, and some help pages will be a bit like this, a bit cryptic. But here, what we already know what they want is a string, character string. That means basically a sentence in between quotation marks, and in this case is the directory you want to change to. And it has a lot more different things. It has nodes, it has other functions you might be interested in, etc. And sometimes there's examples as well, which is quite good. So let's just have another look at a different one. Let's look at mean. Okay, we used this one briefly above, so let's look at that. Arithmetic mean. Description, generic function for the trimmed arithmetic mean. Then it tells you the usage. Again, here you can see that there's a mandatory argument, which is the first one, and then there will be a list of optional ones. So they use like the ... here, and then it lists the argument. So the X, which is the mandatory one, is an R object, it then explains a bit more what the type of object needs to be. And then there's a few other arguments you can specify. So this is the help pages of the functions are useful in many cases. Sometimes they're a bit cryptic as well, just to be completely honest with you. But it's always worth checking and then Googling anything you don't understand. Another good thing is if you're writing in this forum, sometimes they ask you, okay, I need to know a bit more about your R version, which packages you use, the versions, all of this, what you have loaded. A way of quickly checking that and then copy and pasting that into the forum, or just checking for yourself, if you have to specify, for example, the version of a package you used in an analysis. A quick way of doing that is to do session info, and the I here is capital I. So R is sensitive to case sensitive, so it's important to write in lower letters if it needs to be lower letters, and capital letters if it needs to be in capital letters. And again, this is a function that doesn't need any other arguments, so you just run that and it will give you a list. So it tells you the version, the R version. Mine is probably a bit older than yours because I haven't updated it. It tells me my computer, like my platform, my OS, and then a bit more other other information that I don't understand. But then it says, for example, what base packages it has. So these are packages that come in R, and then if I've loaded anything else, it'll also show here. So if I loaded ggplots2 by doing library ggplots, that will show. So these are just a few ways of you asking for help or checking different things. Honestly, Google will be your best friend when you're coding. When I started coding in R, I bought a massive book that cost me quite a bit of money called the R Basics or something. It's a great book. It has everything you need to know. And I might have opened it like twice because all the other times it's just quicker to Google than to look at what's in the book. Right, so I said we were going to look at data structures next week, but actually we're doing that now. We're not doing it next week, so apologies for that. So let's start looking at more interesting things. I'm gonna get some space here to make it clean. So let's look at something called data frame. So a data frame is essentially a matrix, but a bit more fancy. So if you open a table in Excel, if you're trying to do a bit of data analysis in Excel, and if you have a table, let's say with the age of the participants of a study, then their glucose values or whatever, that table, if you import that into R, that will be a data frame. Okay, so it's essentially a table with rows and columns, and the columns can be of different types. So one can be words, and another column could have numbers, etc. So let's create a data frame called cats. Okay, so I'm creating a data frame and I'm saving it in a variable called cats. So then I'll have an object called cats, which is a data frame. Okay, so just to use all the jargon together. Then I use the assignment operator, and I'm going to use the function data.frame to create this data frame. And inside of the brackets, I'm going to write the data into the different columns I want to create. So the first column I want to do is the code equals. And here notice that I didn't use the assignment operator because I want to, how do I explain this? I want to attribute the next vector into a column of the data frame. So in this case, I'm using the equal sign. This is why I feel personally it's better to use the assignment operator in any other scenarios, because the equal sign has actually quite specific uses sometimes in R. This one being one of them, of when you have arguments as well of a function, you'll do the name of the argument and then equals the value you want to give to the argument. So I prefer to leave the equal for these cases and use the assignment, this assignment operator in any other cases. So now I'm going to make a vector of 3 names of fur coats in cats. And to create a vector in this case, I'm going to use a very useful function that we use a lot in R, which it's C and stands for combine. So C is just, the function is just C. And inside I'm going to write 3 words separated by commas. So the first one is calico, and I'm sorry, I'm going to butcher a lot of these names. English is not my first language, and I don't know how to pronounce some of these things. I think it's calico. I have no idea. The next one will be a black cat. So I'm going to write black. So I write a comma in between each of the words, and I write the words in quotation marks. Again, it can be double quotation marks or single quotation marks. And the last one will be tabby. Okay, so you can, if I go to here and if I put the cursor after these bracket, you will highlight the one that I'm closing, which is quite useful actually. So this bracket closes the C function, and this bracket closes the data frame function. So now I have a function inside of a function. So I have specified the code. Now and the next column I'm gonna have is the weight of each cat, and then equals. And here again, I'm using the function C, and I'm going to write 3 different weights. So 2.1, then 5.0, and then 3.2. And these are my 3 weights of the 3 cats. Then again, the final column, which I've been teaching this course for a while now, and I still don't know what this column is supposed to mean, because they don't use it anywhere. But we're going to keep it exactly as it is in the exercise. So it's likes string, underscore string. That's the name of the third column, equals, and then C. And here is just going to be the values of 1, 0, and 1. I suspect this came from a different exercise and where this was used, but I never used it in this course. But anyway, we'll add it anyway. So now if I run this, it has, sorry, I'll push this down. Do you remember that I cleaned my environment using remove? So I didn't have any other variables here. And now I created a variable, and it tells me here that this data set has 3 observations and 3 variables of 3 variables. So 3 observations, each of them have 3 variables, which is correct. Now, let's say I want to send this data set to anyone, or just save it as a table, so then I can go to Excel and do other things. I want to save it as a comma separated value, which is a very useful file type. So it's similar to a plain text where things are separated by tabs, but it's the values here are separated by commas. And when you load it into Excel, you can then, so it's basically like it would be an Excel file, but without all the formatting. So the CSV is to Excel what a plain text, a notepad file, for example, is to Word. That's how I like to think about it. So we're going to write it as a CSV file. And to to do that, I use the function write.csv. And then inside, I'm going to do x equals cat. So x is the file, the object I want to write into this file. Then the next argument is going to be file equals. And now I'm going to write the name of the file. Now, if I want to write the file into the working directory where I am, I can just type the name of the file in between quotation marks. If I want to write to a specific folder, this is what I was mentioning before, you write the full path, for example. Or if you have a folder inside of a folder, you could just write the folder and then the name of the file. I want to write just in my working directory, so I'm just going to call it feline data. You can call it whatever you want, .csv. Okay, now if I write it like this, before I write this, actually, let me type cats and just so we can see it in the console, what it looks like. Okay, so if I get the output from cats, I have 3 columns. Those are the 3 columns I created. And here, 1, 2, 3 is basically the row, the row names. So I could give it row names, but because I didn't, it just numbered them 1, 2, 3. Now, if I just write .csv like this, you will create a column first where I have the row names. And I don't want that because I don't want it to add 1, 2, 3 to the beginning of my data set. So I'm going to add another optional argument called row.names equals false. So the default of write CSV, if you go to the help page, is row names equals true. And I want to change that to false, so then it doesn't write 1, 2, 3 at the beginning of my file. So let's write that. And I'm actually going to open it. You don't have to open it, but I just want to show you. If I open it, this is my equivalent of Excel. It's very similar. And when I open it, Excel might not do this. It might just open immediately. But to me, you see how it shows the values separated by commas. It asks me if my separator options are in tab. I'm actually going to say they're actually in comma. And now it has transformed it into a table. So if I do that, it just opens. Some Excel versions will open straight away. We'll just recognize it. Some you'll have commas, and then you can go to data and text to columns, and then you'll have the same thing, and then you just click comma. You have to select everything. So this is just to show you that you can create the data frame in R, save it to your computer, and then open it in Excel. If I hadn't put the row names false, it would have added another column here with 1, 2, 3, and nothing on the column names. You can try that if you want. You'll see that that's what happens. So let's say that you didn't, I'm sorry, I wrote that in the middle of several lines. So let me just tidy this. Okay. So let's say that you have the data set already in Excel, and you want to import it from your computer. You haven't generated it in R. Usually you would actually already have a data set. You're not generating it, saving it, and then loading it again into R. So I'm going to remove the cats from my environment just to show you how you would load the data set. So again, I'm using the function remove, and I'm going to write cats just so it's gone. So you see my environment is clean. You can check it by doing ls as well. There's nothing. Character 0, that means nothing. And now I want to load my cats data set. So again, you can use the full path and then the file name, or you can use just the file name if you are already in the folder where the file is saved. Okay, so the function I'm going to use is read.csv, and then quotation marks, and then I'm going to put the name of the file or the full path plus the name of the file at the end. So now I'm going to show you the full path option just so you can see. Again, I go to my folder, I copy and paste just so I don't make any typos writing the path. And then I'm going to paste it and then add a slash, and then I'm going to write feline data.csv. Okay. If I just run this, it will run it and output it in the console, but it hasn't created a variable called cats. So I need to attribute this to a variable called cats. Okay, so now it's going to read the CSV and attribute it to the name cats. Let's run it. And now I have a variable called cats. Again, it's the same as before, three observations of 3 variables. Let's type cats and actually have a look. There you go. Again, it added the row names here, but if I hadn't done row names false, you would have added those row names as a first column, which is a bit annoying. Oh, actually, okay. So let's have a look at this help page, read.csv. Okay, data input. Usage has loads of different optional parameter arguments that you don't need to know. There's variations of the same function. So this one is read table, read CSV. Read CSV is kind of a special case of read table. So if you have a table in text file, you would use read table. But if it's in CSV, I believe you can use both, but it's more common to use CSV. And you can see this is a case where it's a bit more of a more complex function. So it has loads of different arguments, and I wanted to show you that as well. And here you can also say specify the row name. So imagine that you actually had names for the rows and you saved it with this equals true, and then to import it and read it as row names, you could do row names equals 1 if I'm not mistaken. So then you're saying the first column will be the names of your rows. There's another option, which is we're going to add, but then I'm only going to explain later because that's the structure of the course, unfortunately. So we're going to add an option called strings as factors, and the A and the F are in capital letters, and basically and equals true. And basically what this means is that it's going to take any it's going to look at the columns, and if possible, it's going to convert them into a factor. And we'll look at factors in just a bit. Okay, so bear that in mind. So I'm going to rerun this. And now I have cats, and it's going to look exactly the same. So let me pull this down. Okay. So ways that you can look at the different columns. If the columns have names, we created names for our columns, code, weight, and length string, is using the $sign. So let's say I just want to look at the values of the weight column. I can do cats, $sign, weight, okay? And if I run that, it'll give me a vector with the 3 values in this column. I can do the same for coat. And again, now we have levels, okay? So what it has done here, because we did strings as factors, it has taken the whole of the column and took every single unique observation, and it created a factor. So this is a factor, and the levels of that is black, calico, and tabby. Let's say you had the sex of your participants, and you have a data set with 100 participants, and in that column you have M or F for male or female. And if you do strings as factors equals true, it will take that column and generate a factor where it keeps all the values of every single participant, but it knows that the 2 possible levels are male and female. So then in levels, you would have M and F. And factors are useful. Sometimes it's best to do this with strings as factors equals false, but factors can be useful when you're, for example, doing plots like box plots, where you want to do it by sex, and then the R will know that that column is a factor, and then there's two levels to it. So you'll separate the data into the two boxes of the box plots, and you'll automatically take the rows that belong to M and the rows that belong to F and output it like that. Yes, that's it. That's what I wanted to say about factors. It can get a bit more complicated, but I think this is a good introduction to factors. Now I can take columns and do what I was doing before, what we were doing before, which is like operations with them. So I know that the cat's weight is a numerical vector, so I can add you know, values to it. So let's say I want to add let's say we have the weight, and we discovered that actually the weight was in it's off by 2 kilos, and we want to update the values of our weight. So I can do cats weight and then do +2, and that will update all the values. This will not update in the data frame. So if I do cats, the weight is still the original, it's just the output will be updated by 2. I think we'll look at how to add new columns to the data set a bit later on. Another thing I can do is, for example, create expressions or sentences with a column. So let's say I want to write the sentence, my cat is, and then one of these 3 codes. I can do my cat is calico, my cat is black, my cat is tabby. I can use the function paste, and then inside the paste is going to literally paste 2 values together, or whichever values we're putting inside together to create a sentence. So if I do paste and then use quotation marks, and my cat is, so this is the sentence, and then comma, and then cat's coat. Okay, so this is going to do is take the sentence my cat is and paste it to each value of this column. So if I run that, my cat is calico, my cat is black, and my cat is tabby. So it created as many sentences as there are entries in this column. But are there any questions now? Okay. So let's
Sorry, can I ask a question?
Yes.
If for this strings as factors thing, if you had a string there twice with 2 different, so for example, there were 2 black cats, one was 5, whatever units we're using, and the other was 10, would the strings as factors pair that color with both of those? Do you see what I'm meaning? Is it making a matched data set here, or is it going to pool both of those numbers together as both under the black?
No, it will still know that each row is an individual entry observation. Okay. It's just how you want. It's just how it combines, but it doesn't mash up. If you know what I mean. So if you want to plot it with, let's say you want to do a bar plot, and the first bar you want it to be all the black cats, and the second one all the tabby cats. Let's say you just have those 2 levels. Let's forget about the other one. So in my data set, I have those 2 levels. You can say group these values by the 2 levels, and you will group them, you will plot them like that, but it doesn't mash them up. They continue as individual entries in your data set. Does that make sense?
Yeah, I'm just trying to understand, because you were talking about male and female, and I'm just trying to think about how that I'm sure it'll work out in the end, so don't worry about it.
Yeah, let's this is always a phase where I don't know how to show it.
No, I'm sure it's one of those things that will suddenly click later on in the lesson, so don't worry about it.
Okay.
Thanks.
I don't even know if I should, like, when I teach this, I don't know if I should mention factors here, but they kind of mash that up with the strings as factors argument and then don't explain it properly. So I always try to find ways of explaining it, and it's not always the easy. I don't know if Rebecca is.
I went to one of those tutorials a year ago, and I think they explained it with a simple experiment when they had 3 strings to play with for the cats, and they were just recording which strings the cats preferred.
Okay, yeah, I don't know if I get that.
They showed the cats, they had 3 cats, they showed them strings, and they were playing with the strings, and they recorded which string the cat chose, which string the cat wanted to play with.
Okay. And how does that relate to the factors?
I don't know.
Okay. Okay, I'll think about that. I'll see if I can find that.
Can I ask the question a different way?
Yes.
Which is that strings are factors, but numbers are not factors. Is that correct?
So the strings don't have to be factors. Strings are literally just sentences,
characters,
words,
right?
Yeah. But you can group them into factors. I believe you can't do that with numbers, but you might be able to do that with integral numbers.
Yeah. Okay.
You might be able to do it. So if you have like 1s and 2s, I
think
group that. You can definitely group that as factors. Yes.
Non-continuous variables.
Yeah, exactly. So as long as it's very obvious for R that there's categories of.
Yeah. Okay. So factors are kind of like categories, basically.
Yeah, exactly.
Okay.
Yes.
Okay. Got it. Thank you.
If you have cases and controls, like cases of a disease and a control, for example, to throw at a t-test or a linear regression,
right,
you could have them as factors. That would help you then.
Okay. Okay.
Yeah.
Okay. Thanks a lot.
No problem. Let's talk about data types. These are the things that you don't need to memorize or know. It's just an important thing to be aware of, because some of the errors will relate to the data type. So sometimes you're trying to do something that it's not allowed with that data type, and it's good to know the different data types, or at least that they exist and you can go and look them up. So let's look at the data type of cats, that it's stored inside of cat's weight. So we know the values, but let's look at what R says they are. So if I use the function type of, and inside I do cat's weight, and if I run it, it comes as a double. So double generally is just a number with decimal places. So if you have 1, I think it'll still show you as a double, because R is thinking is 1.0000000. Okay, let's try that actually. Type of, and then if I put 10 inside, it's still a double, because for R this is 10 equal 10.0000, even though it just displays the 10. If I do type of 3.14, this will be double as well. Yeah. If I wanted to come back, if I want R to interpret a number as integral number or integer, however that's pronounced, that I never know, integer, I believe, you put an L after. So if I do type of, and then do 3, and then a capital L, R will say this is integer. So R is interpret this 3 as not having any decimal places. It's just it's just the 3. You can do this with, if you can use complex numbers like I. So I can do type of 1 plus 1i, and R also recognizes this as a complex number. Other types of data, true and false. We've been using quite a bit of things that have given true and false as a result. So let's have a look at true and false. Both of them will give the same result. It's a logical data type. Okay, so every time you have an argument that you have to specify if it's true or false, because you're not using the quotation marks, it's not a string, it's not a word, it's interpreted as a logical value. It's either true or false. There's only 2 options there. finally, let's look at a word. So type of, type of, and then again, quotation marks, single or double, it doesn't matter. Let's say, what's banana? Character. Okay, so it's telling me it's characters. If you have like a full sentence, you can also call that string. I mean, I can also call this string. I don't know if it's specifically exact, if it's really exact to call this string, but I probably would call it string. But I think string is more for a sentence, for example. I think, I'm not sure. But when we say character, that's what it means, is that it recognizes this as letters that can form a word or a sentence, etc. It's not numerical. What else can we? So this is for types of data, so single values, etc. But what about cats? Something like cats, which is a data, we already know it's a data frame, but how can we check that it's really saved as a data frame? Or how can we check if we have a different object? So some packages create quite like objects that are specific to that package. They develop their own objects and classes of their own. And sometimes you just want to know, because you want to go and post a question in Google and you don't even know what you look for, because you don't know what type of object you're dealing with that package has created. So a function I use a lot for actually to check that, it's class. And then inside you put your object. So if I do class cats, it's a data frame. Okay, so now I know it's a data frame. Sometimes it's like a matrix, or it could be a S4 something. It can be, when objects are quite complex, it can come back with an obscure name that you can then go and Google about. At least that's what I do. So let's look at vectors again. We already created vectors by doing the 1 to 5 and using the C function. But you can also create a vector. Let's create a vector called my vector, and then use the function vector. Sorry. And let's just say that we want the length. We're not going to actually specify what we want inside of the vector. Let's just say length equals 3. Sorry. So we're going to create a vector with 3 elements, but we're not telling R what we want it to be inside. Oh, length is it's misspelled. So here, actually, I should explain the error. Error in vector length equals 3, unused argument. So it looked at the list of possible arguments for this function, and it said, I don't recognize this. This is unspecified. So it threw an error. And that was just because I had misspelled length. So if I run that, and now I looked at my vector. And so if you don't specify what, so in a vector, all elements need to be of the same type. So in this, we just saw the different types of data. So in a vector, all the elements need to be in the same type. And if you don't actually tell R what you want inside of your vector, and you create a vector with this function, you'll just default to logical type. So it just wrote inside of my vector, false, false, false. This is just the default behavior of vector. Let's say I want to actually change the data type that's inside of my vector, but again, without specifying what I want. I can write another vector. Yeah, and again, do vector. And here I'm going to say specify the mode, which is an argument, and the mode I want to be character, which is one of the data types we just saw. Banana is the type character. And then length again equals 3. So let's run that. And then another vector. So it just created a vector of 3 empty character strings. Okay, so I told them I didn't want a logical vector. I wanted a character vector. So, but I didn't say what I wanted inside. So it just created 3 empty spaces for a character. Another good function when you're trying to assess what an object is or how R is interpreting those values to be, it's the structure function, which is str. So let's look at the structure of cats. So it's telling me that cats is the data frame, and it has 3 observations of 3 variables each. And then it's listing each of the columns. The first column is code. It's a factor. Okay, it's telling me that it's interpreting this as a factor with 3 levels, and then it lists all of them, and it actually doesn't list all of them because you can't see them, but it tries to, and then it puts ... The second one is weight, and it's a number, and then the final one is an integer, which is the 101. What else? Let's try and produce a vector with 2 different types of data, which we know it's not allowed, and see what happens there. Okay, so let's do a vector called quiz vector. And then let's go back to using the function C to combine different values. And I want to make a vector with the number 2, the number 6, and then the number 3, but as a character. Okay, so inside of quotation marks, again, double or single, doesn't matter. But I'm aiming that it will create a vector with 2 numerical elements and a character 1. It has created it. It hasn't given an error or a warning message. So let's see what it actually has done. So it went through all of them. It realized that one of them is a character and transformed all of them into a character. This happens if this was a letter as well. It will just take all these numbers and default to a character. This happens with all of the others, I believe. So let's try putting together a character element and a logical value. So quiz. So this is called coercion. So that means that R is it's having to make a decision of what to transform the data into, and it defaults to a character. So quiz vector 2. Let's say we want to combine the letter A with the value true. Now, quiz vector 2. Yeah, so it transformed the logical value true into a character, and we know that because it's used quotation marks. We can also, I believe, do class. I'm not sure if this will work, but I think we can do class vector 2, and it might tell us, yeah. So it's telling me that the class is character of the whole vector. So it has transformed both into characters. Now, what happens if you combine a number with true or with a logical vector? Let's create a quiz vector 3. And let's combine the number 10 with false in this case. And then if we run that, it has taken this, the false, and it has transformed it into the value of 0. So if I had true here, this would be 1. So the way R codes the false and true is 0 and 1. So false is 0 and true is 1. And here it just had to transform it into a number. So it took the numerical value of true and false. So this is, it might not sound important, but it is, because as you see, R has never thrown an error here. So it is changing the nature of the data. And this is quite important to be aware that it happens when you're working with data sets. For example, an example that comes to mind that has given me issues in the past is one. So you can have values as NA, non-applicable. So R will know those are void.
Oh, C, I forgot the C.
Right, can you see my screen? Let me just create the cats again, because I think if we need it, I'll create it again. So I don't know what was the last thing you heard me say. Can anyone tell me? I was talking about coercion, right? So so I said it defaults to this one. Let's just run that again. So it defaults to the numeric when comparing numeric with logical. What if you wanted things to be numeric? If you're putting, if you're doing this one, for example, sorry, the quiz vector, let's copy and paste that below just so you can see. What if I want this to be numeric and I don't want it to go to the default? Then I can do, for example, as numeric quiz vector, and then I can force it into a numeric. And you see now there's no quotation marks because it has transformed this into a numeric vector. I can also do that as logical. So let's do it with this one and see what happens. It might throw an error because 10 is not either false or true. So let's try s.logical quiz vector 3. And if I run that, okay, it has created a true here and then a false. I don't know if it takes any number that it's not 0 and it turns it into a true, maybe. Let's try it with as logical, and then see, let's create the vector inside of this, and let's say 30, 100, 0. You remember the 0 was the false. Let's just try that. So yeah, it apparently it takes the 0, that's a false, and any other number will be a true. So that's just important behavior to know. Oh, I was talking about coercion problems. That was the problem. That was what I was talking about. An example I had in mind is just something that happened to me. When you have NAs in your data set, but R needs to know that it's a missing value, it needs to be in this format, okay? It needs to be an N and an A. And some data sets will come like this, some data sets will come like this, and R doesn't know that's an NA. So then you have like a column full of numbers, and you are adding an NA there that is not a proper NA, it's just a word that R just thinks it's a word, and it's going to transform all of that column into a character, okay? It's not going to see it as numeric because the NA is seen as a word. But if you have NA like this as a proper NA, that R can read it as a missing value, then you'll keep it as a numeric column. So that's an important thing to keep in mind. We're nearly done. I'm just checking if there's a couple of other things that it's important. Let me create cats again, just so I can show you. I need to create it again because my computer crashed, so it's not in the environment anymore. So I'll run that. Let's say that you have a much bigger data frame than this that has like thousands of columns and thousands of rows, and you want to see you want to do what I just did, which is output the data frame just to have like a visual of what it looks like. But obviously if you output the whole thing, it's just going to be lines and lines and lines of output, and you won't get a sense for it. So two useful, very useful functions are the head function. So let's do that. Head of cats. This will give us exactly cats because cats is small, but head will give us just the first, I believe it's 6 columns and 6 rows. I don't know if it's 6 columns, but it's definitely 6 rows by default. So I can change that, and I can say, give me only the first 2 rows by adding comma n equals 2. And now it'll just show me the first 2 rows of the data frame. So this is a great way of inspecting a large data frame, and you just want to look at the beginning of it to see like the column names and the way the data is structured, etc., without having to open Excel, loading the data set, etc. Another good one is tail. So that looks at the last 6 rows. Again, it's going to give us the whole data set because cats is small, but again, I can specify, let's say 3, n equals 3. It'll give me the last 3. Oh, in this case, it doesn't change anything. Let's do 1. Yeah, so it'll show me, still shows me the column names, which is very useful, but then it shows me the last row of the data set. But the default, I think it's 6. Right, I think there's more about factors, okay, in here. But I'm kind of tempted to, if you want to know more about factors, to go and read it. And there's a couple of exercises, just because we can't fit everything in 2 days, but there's a little bit more about factors, and there's even an exercise. So I recommend you go and do that. Let's talk about lists for the last few minutes. So another data structure you can have is a list. So a list is different from a vector because it's a bit more structured. Let's create a list. Very non-imaginative name, list example. That's going to be the name of my list. And to create a list, I use the function list. And I want a list with the number 1, the letter A. So in this case, you can combine data types with no problem. The value true, the logical value true, and then the complex number 1 plus 4i. So let's run that. And then let's look at the list. Okay, so this is what the list looks like. This is the first element of the list, the second, the third, and the fourth. Why do you have this number is because the first element can actually be a vector, or you could have many different other elements and so forth and so on. So that's why I meant the lists are way more complex. You can make them quite complex. And let's say I want these 4 things or these elements to have names. So let's say I want to create another list, which is a list, and then I'm going to say the first element, I want to call it a title, and I want that to be the word numbers. Then the second element, I want to actually be the numbers. Okay. And I want a vector of 1 to 10. And then the third element, I wanted to call it data, and it's just going to be the value true. So let's run that. And if I look at it, now each of those elements of the list has a name. So the first one is the title of my list, which is number. The second one is the actual numbers I have on my list, and then it's the value true in the last element of my list. So you could have as complex as you want list with many different elements and then loads of data inside of that element. So lists can be quite useful when you're working with large data sets and complex data sets. So I think that's it for today. Let's just do a little bit on subsetting, which is to call different elements of a data frame or a list, just so before we finish. So let's say I want we already looked at how to call columns, right? So weight, right? So this calls one of the column that's called weight, but I can also subset cats in other ways. So I could do cats, and to get the second column, I can do the square bracket. So that tells R that I want to subset values of this data frame. And the first value I give it, it's always the row index. And the second one will be the column index. So if I don't specify the row because I want every single element in the column. So I want all the rows, and then I want the comma and then the second column. So if I do that, it'll be the second column is actually the weight column. So it's exactly the same as just calling it by the name. Or I can subset it with just one element. Let's say I want the second row, the third column. So I'll do this, and this will be the value that's stored in that index. Now in a list, let's say I want to call the second element, which is the numbers of this list. I can do another list. And in this case, I use double square brackets because it's a list. And then I want in the list, the first subsection, that's not a word. The first way of subsetting is to use the double square brackets for those three elements. And then further on, you could use the single ones to subset elements of that element. So let's try another list and then two. So this will give me the second one here. So the numbers. If I do that, it gives me all the elements of that second part of the list. Now, if I want just the third element of this, I can now add, I think this will work. I can now add the single square brackets and do third, and now it's given me the number 3. So let's look at this list again, just so we can visualize it. So another list looks like this. First element is title, second is numbers, third is data. So to select this one, I did the double square brackets, and I wrote 2. And then to take the third element of this second element, I used like I would subset a vector, for example, then I use the square brackets 3. Okay. I think that's it. There's 3 minutes for questions. I know I talk a lot and fast. I don't know if it would be better if I gave you less content, but let you have a breather. I don't know. Are there any questions? Or everyone is lost? No questions? Okay, well, I hope I didn't lose you all today. I hope it wasn't too much and you could follow and code along. And I hope I see you next week. So thank you very much for coming.
Thank you very much.
Thank you very much. That was really great.
Oh. Thank you.
Thank you. That was very nice and clear. Thanks.
Thanks, Joanna. It was perfect.
Thanks.